Well, welcome everybody to another episode of the Most Important Conversations, where we try to cover the most important conversations humanity needs to be having right now on several different topics. And today we are really blessed to have with us Smith Johnston, who served as medical officer and operational flight surgeon for NASA medical operations for a little over 30 years. And he retired in 2019. But Smith, it's such a joy to have you on the program today. I'm so excited to be able to talk about health and wellness related topics, but from the perspective of space, which, as everyone knows today, is a hot topic again. It's so interesting that when I was growing up, there was like Star Wars, and there were all these movies, and space was a big thing. Of course, just a few years prior to that was the moon landing and a lot of the exploration that NASA was doing. And then there seemed to be this period, at least from a sort of layman's perspective, where there wasn't a lot going on with NASA in terms of space exploration and stuff, the way that, we thought that it was going to go after we had landed on the moon, and we thought that there was going to be this, expansive period. And now all of a sudden it's back up there again, with everything, with what, all these different private launches that are going on around the world. Space exploration has really come back in the limelight. And, you were sharing with me, just to kind of move into your background, that, space is among the most hostile environments, if not the most hostile environment on the human body. And so tell us a little bit about your background from a medical standpoint, in terms of what you've done in your career, and then we'll kind of transition into a dialogue and a conversation about space and its impact on the body, and what we can learn from that, and how we can apply some of the things that we're learning about the human body through the understanding or the framework or the lens of space exploration that might create some pretty interesting advancements for us here on planet Earth. But let's start with a little bit with your background with NASA and all of that good stuff.
Well, first of all, thanks so much for you and September putting this together, inviting me to this most important conversation. And I'm honored to be here. My background was, I grew up here in Georgia, and I went to school at Emory University and went to medical school there undergraduate. And then I decided to take a year out of med school. And then I took a couple years out afterwards and traveled the country. I was fortunate. I was able to make a decent living at playing music. And that was sort of the only time I felt I could go and do this and kind of get it out of my system, because until I retired, now that's what I want to do full time anyway. But I got to see the country, and I got to interview in all different aspects of, I was interested in everything: emergency medicine, surgery, OBGYN, pediatrics. And then one of my mentors said, the thing that's really going to get you going, you're always going to be inspired by amazing things that happen in medicine, but the things that are really going to get you going sometimes are the things that really, piss you off. And those are things like preventive medicine and end-of-life care medicine. And so I had a chance while I was traveling, and I saw this thing called aerospace medicine, and I'd planned to be a pilot if things didn't work out with medical school. And so I said, what is this? I get to take care of pilots, so therefore I get to fly, and you're taking care of really healthy people. And that's kind of what occupational medicine and aerospace medicine is. I'm just fortunate enough that my patients happen to be, astronauts and some of the best pilots in the world. And so I interviewed with the Air Force and the Navy, and kept looking around the country, and found this program in Dayton, Ohio. So I could do a combined program through NASA, and that's who I wanted to go work for. And I got a master's of public health, and I did internal medicine, and then aerospace medicine at Wright-Patt Air Base in Dayton, Ohio. So I was there for 7 years off and on. And then I went to work at NASA at Johnson Space Center. Johnson Space Center, where the astronauts live. And so so I was there, and then I retired December 19th, and then I worked for a commercial company. So I got to work for NASA all my career, and my career was, like you were saying, there's kind of a lull. What they were doing was actually building the International Space Station, which is the most incredible, biggest module built anywhere. It's 150 billion, I think, to have built it. And it's just an incredible research facility. And now commercially, the company I used to work with and still consult with is Axiom Space. And we're trying to build a commercial space station on the front of that station. So when the International Space Station wears out, like Skylab did, like the Russians have built 5 or 6 space stations. So when that when they go off, burn up in the atmosphere, then that station will be a commercial space station. And why commercial? Well, for people to come and go, it's costs a little bit. It's around $65 million for a seat, but it was costing us more than that when the shuttle went away and we were using the Soyuz. It got up to $95 million a seat. So we're kind of trying to get those prices down. But the big thing is to actually take very, very healthy people and put them in very unique environments. And being in outer space is very, very unique. It's actually an accelerated state of aging. So you've got 10 times the radiation because you're closer to the sun. And the farther we go out from the Earth, the less we're protected by the Van Allen belts. The Earth, we're going 1,000 miles an hour right now. And that we have an iron core, so that makes a magnetic force field that keeps us from getting pickled from solar flares when they occur. And so, but the closer you get outside that Van Allen belt and the closer you get to the sun, the moon is 234,000 miles from here. Moon and Mars could be 30, 40, 60 million miles away, depending. So those are two big leaps. So NASA is putting all its energy now, after building the space station, into building another space station around the moon. And then they're going to put their money into the Orion program to go to the moon and colonize the moon. In a similar way, we did the South Pole. And that's one of the models we use. But anyway, let's go back to the reason, what we were talking about is you've got 10 times the radiation. You've got 10 times the bone loss because you're floating. You've got essentially 10 times the carbon dioxide, and I would tell you volatile organic compounds that are in a closed loop environment. We can't scrub the carbon dioxide. So that carbon dioxide actually has an effect on your blood flow to your brain. Think about it. 15% of your blood that's in your feet right now, when you're in space and you're weightless, it goes to your head. And if you're breathing all that carbon dioxide, that's a potent cerebral vasodilator. So we actually have problems with head congestion and then the bone loss. We have to have them exercise all the time. They get 2.5 hours every day dedicated to setting up and exercising to keep those bones strong and the muscles strong because you're floating. You're also traveling at Mach 25, 17.5 thousand miles an hour. So you see a sunrise and sunset every 45 minutes. So if you happen to go look to the cupola to see the windows and to see a sunrise and you get all that blue light right before you're trying to go to bed, that totally smashes your melatonin and disrupts your circadian rhythm. So circadian rhythms and desynchrony is something we work with all the time. Fatigue management. In fact, while I was at NASA, I think I worked when I got there in 1990, I worked for a private contractor, and then I got a job in 94. And my job was to build the emergency medical system for the space station with a group of other, a ton of great people. I was just one persons on there, but we actually had to go prove that you could do, like we have a defibrillator, we have a ventilator, we worry about doing a spacewalk and getting electrocution or taking an orbital debris hit that's going 17,000 miles an hour in the opposite directions. They've had them hit the windows. They had them hit the Soyuz with a leak here recently. So really concerned about that. And if you took a ding to your spacesuit, you'd have to try to get in and take care of somebody. Or if they went into a dysrhythmia from electric shock from on board the station, or there was a fire, we have to have the ability we can intubate, defibrillate, and do all those sorts of things. So as we built the space station and learned to live for years, I mean, think about it. Since 2000, we've had the first elements went up in 1998. We've had a human presence in orbit that whole time. And taking care of those folks to make sure they don't have the bone loss, to make sure they don't have the inflammation caused by this radiation. One of the talks I like to give is space medicine terrestrial applications for human health, performance, and longevity. So again, if you're putting these astronauts who are very healthy, capable people, and that's what occupational and aerospace medicine is, you take healthy people and put them in a really funky, unique environment. And it takes them a while to get their vestibular system coordinated and just to settle in. And they're also in an isolated form. And we also have a team of psychologists and psychiatrists that help us with the families and with the isolation and the training. It's a tough job. These astronauts it's again a real privilege to work with them and over the years. And I have retired from NASA, but I still am on their alumni, and I still am on many advisory boards and the adjunct clinical faculty at University of Texas Medical Branch, which is where we train residents to be aerospace medicine physicians, and also we train the polar medicine folks too. So there are a lot of analog populations that we look at. And I'm throwing a lot of stuff out here, Chad. Just tell me. You can obviously tell I like to talk, and you go, calm down.
No, it's
September, keep us together.
I love it. I'm letting you just set the context, and I'm left with, based on just your introduction of the complexity around all of this, I'm left with this thought that, man, do we take a lot for granted in terms of our health and well-being and its relationship to the environment and the atmosphere that is planet Earth, nature. I mean, we take so much for granted.
We do, and it's why are we going to space? It's to learn about our environment so that we can take care of the most precious thing that we live on, and that's planet Earth. And we're kind of mucking that up. We've had 5 major extinctions since the 13 and a half or 14, 15 billion years we've been here. And if we don't take care of things, every 100,000 years, we get a little 12,000, 20,000 blip of global warming. And it has to do with the orbit of the Earth around the sun becomes more elliptical. The axis of the Earth switches, the direction switches. So every 75,000. So all those add up. And then we get this little global warming blip, and we should be cooling now. The problem is the carbon dioxide, as we do this, has done this. It's up here. And so if we go too quickly and we melt too quickly, then all those methane pockets underneath the solar, the ice caps release, and then we greenhouse gas our place. So that's the thing we've got to make a dent, and we've got to start making a dent soon. And that's why we're up there is to help take care of the Earth. And not only monitoring, now can we monitor everything that goes in our body pretty much, but from space station, it's an orbital observation tool for looking at how the different changes from our atmosphere when we go into space, which is space is considered 100 kilometers, 62 miles. But watching how the Earth breathes, how the oceans change, how we monitor the Earth is a huge part of what we do. Just like we've got to be monitoring those astronauts to make sure they're not losing, 10% of their bone mass in the course of or 20%. And that's the good news is what we've learned is you can lose that. And the human body is so adaptable. And we didn't used to think you could, once we burned brain cells, that was it. We now know we can regenerate brain cells. And there's just so many exciting things that are happening in medicine and then when we're able to put people in this advanced state of aging and then see if we make a difference, then that is something that just like, all the NASA spin-offs that are out there, that's what we're here for. And that's something that I think it's been my joy. And now the last 4 or 5 years I was at NASA, I ran the flight medicine clinic. And one of the great joys I had was not only taking care of the day-to-day care of the astronauts, but also the retired astronauts. I mean, we have 36 astronauts now in their 80s and 90s with all this incredible data on them, from cholesterol numbers to strength. I mean, we know it's pretty much knowing, and then we're starting to be able to do genetic testing on our astronauts. That's something that's big. So just for all of us, it's about 7 to 10% for any of us listening to this. Yeah. Are our genetics, and the rest are how our epigenetics. 7 to 10%. That's it. That's it. Yeah. I mean, I used to say about 20% are genes, and now the latest things on some, as far as really making effect, it's how your genes react to certain foods. You can eat certain foods. I can't. It's individualizing. That's where medicine's going. And that's what we've always done with the astronauts with precision medicine. You're taking an individual in this unique environment with this set of tools and nutrition and medications to get them through this 6 month to 1 year ordeal of being up in space, which is, and things break, we've got to fix them, and things happen on the ground. We've had, people getting car accidents. We've had a lot of interesting psychological issues that go on, like we all have every day with all our families.
Go ahead. I got a couple of questions on this. So would you say, and then September, I want to invite you in on the holistic side of this conversation, which I'm going to tee it up for a moment. But would you say that we're in a transformative period of medicine right now where we created sort of an industrialized medical system that I think is still what most people think of when they understand Western medicine, but the advancements that, say, space exploration are teaching us in terms of the impact on the body, they haven't trickled their way through the medical system yet. And then so there's a kind of a two-part question. So there's what we're learning from space, which is your world, so to speak, pun intended. That's where you spent your time. And then I'm also observing, and I'm wondering what you think about this, that there's this sort of push to go back towards a more natural way of doing medicine, building, the types of, I don't know, supplements or medications. I have a friend who's a scientist who worked with, I won't say the name of the company, but a very large pharmaceutical company as one of their chief science folks. We're going to have him on the podcast. He's designed and built over 50 cancer medications over the years. And he left this company because he said he believes that pharmaceutical companies need to start moving more towards a more natural approach to how they're actually building medications and the impact that they're having on the body. And he thinks it's possible to get efficacy with a more, what he called, sort of holistics meet science, and bring these two worlds together. What are your thoughts on
No, totally agree. And let's take that a step further. Every time we eat, food is medicine. It's your fuel. So if you can individualize, I think the thing with genetic testing, now we can individualize, not only can we find what our strengths and weaknesses are, but now we can target diseases and we can target foods. Like I know which foods I should avoid because they gin up my immunologic system to fight them instead of breaking out in a rash. They take care of it, but it's spending immunologic capital to deal with a food that maybe is not as bad as giving you celiac disease or something like that. But you might have allergies you don't know about, like casein that's in cow's milk versus goat's milk. There's just differences in peanuts and different legumes and things for different people. So it's actually being able to individualize care for you and use foods to do it, so you don't get to the point where you have an organ that fails or you have a blood vessel that clots, and then all of a sudden you've got to go to a cardiologist. Well, if that blood vessel has clogged up in your heart, then that means you've got blood vessels clogging up everywhere, in your brain, in your kidneys, in your gut. And so it's being able to find those genetic strengths and use them to your benefit, and those weaknesses, and mitigate those through diet, exercise, strength, everything, and sleep. Every one of those things I mentioned is a linear relationship with longevity. And not only just longevity, but it's quality of life. We call lifespan, to have a great lifespan. And we all want to live to, right now, the record's, I think, 122, and get there and just go to sleep and not wake up. That's how we're going to go. And now with the ability to use stem cells, individualized precision medicine, but also with some stem cell therapy, and now engineering, the abilities to fix things genetically in our bodies with CRISPR and others. They're taking care of sickle cell disease, which was just a horrible disease. Yeah. So one of the points to make, and I work with a group called Fountain Life, and they're in Orlando, and that's Peter Diamandis and
Tony Robbins.
Tim Robbins and Tony Robbins and Bob Harari. And it's just and I've got to hear Peter speak a couple weeks ago, but they're actually coming up with this individualized precision care. Helen Messier is our chief medical officer and chief science officer, and one of the smartest people everyone I've met there is just brilliant. But they're able to do like we could do with astronaut physicals. And you can't go spend $26,000 to do an astronaut physical on everybody, but we're able with new technologies and new scanners to now get that to go spend, I think we can get that down to around between 6 and 10,000 to be able to do an entire genetic sequencing, full body MRIs, bone scans, AI programs, brain scans and heart scans. And then you can find things really early. I think they had over 1,200 cases they reported on, and we did a thing on astronaut longevity at the Baker Center at Rice University, Baker Institute, on astronaut longevity. And they basically 14% of people like you and I walking in, I'm healthy. I'm going to be 70 in October. But we walk in with nothing going on, or in their 40s or 50s or 30s. And like Bill Kapp, who's the CEO, says all the time, 70% of what kills you, you don't know you have, and you don't want to die of something stupid. And so if you can find that, and you've got a total body image that as a benchmark to look at yourself further down the road. And now we can look at DNA methylation, DNA damage. We can just see how things are progressing. Yeah. Back to your point, is being able to find exactly, like I was able to go in and find out what my exact zone 2 level is for exercise, and then how much exactly weightlifting I need to do to put on a certain amount of strength, aerobic capacity, both of them just parallel longevity. And that's what we all want to do. We all want to, and then sleep is, I do a whole thing on that. We started a fatigue management system at NASA so we could individualize, sleep medicine for you may not work for somebody else. We could actually individualize it. And we could also test you to make sure if you took a sleep medicine and you woke up emergently, that you weren't, that you could function at a level just as if you woke up and you were in deep sleep from a dream, that you can perform. So we've been able to develop all these kind of fun mechanisms. One of the groups I worked with came up with a thing called Time Shifter, which is if you travel a lot, it's a free download app. If you want to use it, it's free. If you want to keep using it, it costs something. But it basically uses what NASA put together with Chuck Seisler and Laura Barger and Aaron Flynn and Steve Lockley out of Brigham. We were able to use light and melatonin. One of the worst times for astronauts is training and flying to Kazakhstan for a launch, flying to Moscow, flying to Scuba in Japan. And we've also got all these folks in the space stations on Greenwich Mean Time. So we've got every one of the 5 space agencies have their own mission control. So we've got to coordinate that 24/7 capability. And traveling is something now you can just take Time Shifter. You can plug in your fare, not your fare, but your airline schedule, and it will tell you when to avoid light, when to see light, when to take melatonin, when to avoid melatonin. Melatonin's not such a great sleep agent. It works. Your body makes it, but it's a really good chronobiologic. You can use it to help you shift. And then you can also augment that with very short-acting sleep medications. And so we've been able to do a program with that. So that's kind of my benchmark for psychological well-being, is how you sleep. And think of it, sleep is a third of our lives. Yeah. And, it's this kind of stupid thing. We can make it without sleep, but it's dumb. And it's burning up immunologic capital so that we can make it to 120, 140.
Yeah. Our telomeres don't elongate when we're not getting sleep. It's not the kind of stress. It's not the good kind of stressor we want to put on us. So we're really bringing high-tech preventative capabilities now, diagnostic capabilities, combined with a push also in the more natural, holistic direction. September, what are your thoughts on that? And I know you have a deep interest in holistic health, and maybe you've got a couple questions for Smith. I've got a lot for you that I want to dig into in a few minutes. But based on what you just, September,
the questions are building up as you keep talking. So it's like, which question am I going to cherry pick now? I think you had mentioned, Chad, you just mentioned technology, and I'm curious to see what type of evolutions you're seeing with AI being incorporated in pathology. Is there any technologies that's being incorporated in the process of diagnosing different diseases and learning more about the body? Are you starting to see AI in that space yet?
Oh, yes. I'm sorry. I thought you were talking to Chad, and I went off on one of my ADHD kind of things. As far as using imaging and that sort of stuff and diagnostics and AI is exponentially just it's more than a bell-shaped curve. I mean, it's more than a logarithmic. It's more than Moore's curve. It's going to be so special. I mean, think about it. When you can, first of all, yes, we can use AI programs right now. You can go get us a heart scan, and there's an AI program called Clearly, and you can basically put it on there, and it can take all those different scanners. We used to have scanners, a big scanner, a CAT scan that had 64, little slices, little X-rays pushing, and now they're up to 365 and 700 slicers. So you can go in there and you just get a very quick, and you don't get as much radiation, and it will just revolutionize, like mammography. I mean, I think we're going to get away from mammography very soon and go more to MRI and ultrasound technologies and other technologies. The Lake Nona Impact Forum, which I go to every year, which is an amazing place. They had gals who'd actually invented a bra that you could wear that could do imaging and electromagnetic monitoring, so you could do home evaluation. So it's to be able to find a plaque, and again, 70% of what kills you don't know you have. You can have tons of plaque, but it's stable plaque. But if you have an unstable plaque and it ruptures, or if you have a little aneurysm that you haven't detected that you can get rid of, or the other reason for doing total body scans is by the time a stage 1 ovarian or pancreatic cancer shows up, or a stage 2 or 3, I mean, you're done. You don't have symptoms. So we hear stories all the time. Well, you happen to be getting a scan for something else, and it showed this up.
Yeah.
And I didn't go back to the 1,200 patients that Bill Capp presented at our longevity place. Was 14% of people who walked in who thought they were completely healthy had a significant medical issue that they had to get followed, and it saved about 3% of people who came in who had something that was really, really bad that needed fixing. And so with the AI and with the ability, another analogy, September, that I heard you use, that Bill Gates came and spoke with his team year before last at Lake Nona on their AI programs. And one of the analogies was, you put 10 people, you had 10 specialists, 10 physicians. They have grand tumor boards or grand rounds or specialty boards where you've got fascinomas. We just can't figure it out what's going on. So we get a group of docs together, and you talk it through, and you present the patient and try to figure out what's going on. And with a group that came with Bill, he was a pediatric endocrinologist who was a computer science out of Harvard. He says, we get together, I think they were pediatric endocrinologists. And so they'll figure it out about 30, 40, 50% of the time. And then we'll go back and come back and get other tests. In the AI programs, if you put all 30 or 10 people in a room, what AI programs, if you fed them that information, you've just blinked all of those heads together so everybody can be in everybody's head. You've got the same brain power being instantly connected by these giant mainframe computers. And they can go out and have their search engines, and they've also been they've been trained by humans how to notice that you ate this food and your body makes these proteins, and these proteins could give you diabetes, but you could find out way before you got symptomatic, way before you had organ damage, that this is what's going on, and change that. And so that's the whole thing with precision and individualized care, being able for if you use the bell-shaped curve, and this is what this treatment works for the bell-shaped curve, but that could be horrible for the 15 or 15. That could be the worst medicine to give them. And back with the naturopathic stuff, with medications, I've had the good fortune to work with some companies of helping design some medications. I mean, most of the tools we use come from the rainforest and come from plants, and being able to find those plants that work best for you are those medications. I mean, plants aren't stupid. There's some plants, you eat them, you're going to get sick. They evolve like all of us. But finding the right plant, the right nutraceutical, the right medication for you, for an individual, now you can do that with your genetics. And you can now, without having to put a probe in anything, you can just monitor with a infrared light what your glucose level is. And then so it's just exciting. So again, know your strengths, know your weaknesses. Don't get hit by a truck. I used to tell my astronauts, one of the best things you could do in Texas, most important things you can do going out today is when the light turns green, don't go, look on either side, because I mean, how many times we had people run lights?
Oh,
I mean,
yeah. Well, I'm in Florida, so quite often.
I've got in one of my talks, I've got a slide. It's about guys versus gals or something. And two buddies said, I wonder if this bulletproof mask and this bulletproof vest still works. So, well, let's see. And it didn't. So
I'm curious to know
there's some Darwinian things in there. Go ahead.
I'm curious to know about your experience dealing with frequency medicine. My father was a naturopath, and he was really into studying all kinds of, learning about the fingernails and what it's telling us about the body and the ideology and things like that. And then there was Rife machines and utilizing frequency as healing. What are your thoughts on all of that? Have you engaged in that type of technology?
Of course. I mean, vagal stimulation, just slowing down your heart rate, is one of the best things you can do. That's why we were talking the other day. That's why before, taking a deep breath and taking a pause to even say a blessing, if that's what you want to do, it slows down your sympathetic system. You don't want to eat as much or as fast, that kind of thing. So I don't know where I was going with that. Help me out, September. Where was I?
Frequency medicine.
Yeah. So, well, I mean, every medicine out there has come from some plant, some chemical that we've had. So, I mean,
something in our universe. Yes.
Correct.
Frequency. Yeah. It sounds like you really encompass a lot of different technologies in your body of work. There's not just one lane that you stay in. And I think that's really fascinating that you have to study so many different types of medicine and practices. And
there's not an area of medicine that's not impacted. and
I
your
like that.
your eyeballs are different, your vision is different, your neurovestibular system. We have three little areas back here. So when we turn our head, fluid pushes against hair, and that kind of tells us in these directions where we are. And that it takes a while for that to reequilibrate, because now everything's floating. So things are different. And it's just like kind of getting your sea legs. You also, when you've been on a cruise for a long time, you have to get your land legs. And that's where we really, on landing, coming back to one gravity is zero gravity is an amazing place to study, like protein crystals, fiber optics, stem cells, and in fact, medications. A lot of pharmaceuticals are involved with. We want to have manufacturing plants up in orbit so you can make something so pure, and then you can come back. 3D printing in microgravity, so you can print organs and that sort of thing. So that's what Axiom and others. I'm sure there are other commercial space station companies trying to build their own space station, and that's the other thing is that AI will help us with is communication, being able to communicate faster. What do we do now? Siri, or whomever you use, is you can just find out anything. You can sit there hands free and have someone called and heads up display. Holoportation, one of my buddies is really into that. We actually have Princess Leia now. You can holoport 3D images. And now with the new phones, which I don't have yet, with the 3 cameras, you can do some pretty impressive 3D imaging capabilities. And with the new VR
the goggles.
Fascinating.
One of the things that I think we don't even know what we don't know yet, and I'm wondering if you have some insight on this I'm first of all taking the premise that NASA as an organization is far and away more advanced than a lot of organizations. There's probably some other companies that are playing at their level as well, but that you've had the privilege and the opportunity to be exposed to some pretty interesting technologies that are coming down sort of the pipeline, so to speak, that will eventually be available to more and more people. I know that's one of the things you and I have been talking about with the TMIC Recreation Center project and the opportunity to create a wellness center as part of our initiative that brings some of these technologies. But what I was just going to get to is I don't think we even know what we don't know yet about the impact that quantum computing is going to have on our understanding of medicine, genetics. You combine that with CRISPR and some of the other stuff going on, but at a quantum level, I think we're going to be, I really do believe we're on the precipice of curing diseases, things like cancer, because we just don't have the computing power to be able to understand how these different cancers will mutate. But with quantum computing, we can. What are your thoughts on that?
Oh, no, exactly. And now, cancer, we'll get cancer pretty soon. You'll just have a cancer is now an aberrant cell, and you just program your immunologic systems to go in there and take out that, make smart bombs. They're getting rid of leukemias, and just with programming a smart bomb with a killer T cell to go in and then for longevity and repair, there are a lot of creatures out there. It's just really exciting that live hundreds and hundreds of years, certain whales and sharks, and why can't we do that? And why in evolution have we gotten to the point where we stop dividing? And I think some of the promising work with stem cells, with autologous and also donating stem cells, having my old stem cells actually commingle with young stem cells, and the young ones kind of upregulate our old ones so they work better, and our old ones kind of talk to the young ones and go, this is where I'm having trouble with inflammation. And for me, and back to to the TMIC Center and putting that together there is bringing people together with far-reaching ideas and actually being able to put programs together where we can disseminate information, medical information so quickly, and we can screen people so efficiently is where we want to go. But for these stem cells to upregulate and then go, and for me, the most important inflammatory part in our bodies, most people use stem cells. We use them all the time for joints that have gotten beaten up, and now they're healing. Achilles, rupture tears with stem cells, and with using your own stem cells and using donor stem cells also. And now you can have those things upregulated. So when I was saying inflammation, a lot of people want to go get their joints fixed. But I would tell you the most important thing, again, back to blood flow, is your arterial system. And you're supplying blood to your brain. You're supplying blood, the garbage, when you're sleeping, and you actually are, you're unclogging your brain. You're taking those lymphatics, those lymphatic organs, which you've just known about for about a decade now, that were even in our brain, that they actually are taking those tau and amyloid products and getting rid of them. So I don't know, center me back, Chad.
I'm just saying that with quantum computing, we're going to be able to actually we're going to be able to. I think a lot of disease is going to start to get handled pretty quick.
It is, and the point I was getting to is age is a disease. That was my point. And the aging process. So they've increased mice lives by 4 to 5 times with stem cells, and so we're not a mouse, but we're pretty similar. And they're doing studies, of course, on large animals, and a lot of us have signed up. There are a lot of people going and actually having stem cell therapy, not only on their joints, but throughout their entire bodies through IV stem cell therapy. And
have you followed the work of Dr. David Sinclair out of Harvard?
Yes, I have.
So I had the opportunity to tour. He toured me around his lab, and we went to dinner a number of years ago, back in 2016 or 17, I believe. And at that time, he's doing incredible work on age management and age reversal and this sort of thing. He firmly believes that we are going to be able to age reverse ourselves very soon here. And actually has been working on a molecule, he was explaining to me, that has done it successfully with no side effects in mice. What are your thoughts on age reversal and where we're headed with that?
No, that's it. AC11, I think, is the medication. He's got a great book out. Peter Attia has a great book out. Tony Robbins and Life Force, great book. Peter Diamandis just has a new longevity book out that's great. No, it's where we're going. It's treating aging as a disease, and
like a pill. He says you're just going to take a pill.
It's a pill. Yeah.
And he was explaining to me
the other things we got to do. I'm sorry.
No, it's fine. We might have a bit of a delay. This excites me because what he was saying, back then, and I haven't, spoke to him to see how his work has advanced on this recently. But, I said to him, because he says like a mouse will typically live like around 3 years. He was explaining to me, right? And, and he says like, we could take a mouse that has gray hair, arthritis, cancer cells, things like that. And with this molecule, and within a certain amount of time, and I didn't get into what that was with him, but the hair goes brown again, the arthritis disappears, the cancer cells vanish, and I said, well, what do you think? Like, what are we talking, 20, 30 years before we can start to, because he was about to start human trials with it at the time when I was meeting with him. And he said, no, I think within 10 years. He really honestly felt within 10 years we're going to start. And so I just think about this. I mean, am I understanding this right? So if I take this pill, I'm in my late 40s. I'm still the age that I am, but the disease part that you're talking about of aging reverses. Like, am I going to look like I'm 25 again by taking this pill? Is that what we're talking about here?
I don't know. But the other problem that we have to deal with is we can fortify our bodies so that we're getting the right nutrients. We're in good shape. We've got good blood flow, but we've also have this really big problem of environmental toxins.
Huge.
It's really bad. I mean, mercury is in all our fish, not all, but it's, mercury's out there. And I don't mind talking about myself as far as my medical foibles, because I have a genetic marker. I've always done my mercury levels because I work in a mercury environment with, JP4 jet fuel and being around planes and all that kind of stuff, and high performance environments like that. And it's an occupational hazard. But so there's mercury, there's lead, and there's also the latest thing, and I think we talked about it the other day, that I've gotten really torqued about over just the last month, and that's these forever chemicals, and that's the PFASs. So we are evolving from plastic. And plastic can get in your system and really kind of muck things up. They sort of, I don't know if you've heard about senescent cells, but they're basically our older cells that they ain't dead yet. They just
Zombie
hang
cells,
around, they take up space and energy, and they clog things up. And so that's what these forever plastics are doing. And now we've got a way to test them. And now we've had ways to test them. And I had mine tested the other day, but we now have ways to treat getting these things down. And there's a thing called therapeutic plasma exchange that's been out for decades that we treat people. It's the analogy is like getting an oil change. Okay. I never thought I needed an oil change. I just thought my blood, 55% of my blood volume is water, is fluid. It's carrying coagulation factors, but it also carries junk. It carries, antibodies and immunologic markers. Like if you went and you were one of a gazillion people that took a vaccine and had a Guillain-Barré syndrome, they're going to go and give you therapeutic plasma exchange to try to take out. Your body has overreacted to the stimulant and has made more antibodies, and they're affecting other tissues, and they can actually go and clear those things out. Not only will it clear out these antibodies from diseases that you get, but it also clears out mercury. It also clears out cholesterol. So, which I have a problem with, not only abundant cholesterol, but I have tightly bound cholesterol, and I have a genetic marker, lipo(a). And therefore, we used to say when I was training in the 70s and 80s that cholesterol needed to be under 300. And we went, well, no, actually should be under 200. And your LDL, your bad cholesterol, should be under 100. And if you've got lipo, now they're coming out and saying around 60 to 55, your LDL and your total should be under 150. Yeah. And as far as I just went through this therapeutic plasma exchange, there's dilution effect. So we're not sure what it means yet. But my LDL, I take several medications, and I, pretty much vegan based. I'm a pescatarian. But I've got to watch my mercury. So I actually take, because of my genetics, I actually take kind of chelating pills. And that dropped my mercury. And then my mercury, after I did therapeutic plasma exchange, just dropped. And my LDL went, which is usually runs around 35, was down around 7. So this looks like it may be the way to go. And these PFAS chemicals, they made these chemicals so tightly bound that water and fire retardant, they're fire retardant. So the people we need to help the most are the firefighters, because they use the foam. And the foam is what we suck down and gets in us. If you chop on a plastic cutting board, you're going to get 5 or 10 credit cards in your body over the course of the next year or two. So
that's why I only use walnut wood.
Here you go. I got my bamboo cutting board the other day. But what they did with these firefighters, and I know we're probably running out of time here, but
yeah, we got about 5 minutes. Yeah.
What they did, just came out in 2022. They took 300 firefighters and whose level was deemed high, just like they had a high mercury level. They had a high, forever chemical level. And they basically did nothing to 100 of them, said avoid trying to eat plastics, which you can't do. And then they let 100 of them donate their blood every 6 weeks for a year. And then they let another group donate their plasma. And the firefighters that donated their blood had marked levels of decreased PFASs. And the people that donated their plasma, which is about twice the volume of plasma, were dramatically dropped to really, really low. And so that if it works for just donating your plasma, then if you're doing a plasma exchange, which is exchanging 70% of your plasma, then that could have a marked reduction. And it's just too expensive to do. It has to be democratized. It has to be, we have to do enough of this stuff that we can get the word out there. And then people, by the other statistic that Bill Capp presented at our meeting was not only, he had a slide, if you did this test and you found this entity early versus 10 years later, if you found it, the difference in medical expenditures was just much higher and much, much greater. So once we instill the insurance companies to get involved, that actually preventive medicine is good. And Sinclair has some studies, and I've forgotten the numbers, but it's something like increasing the average age in the country by 1 year has a $37 trillion impact to the economy.
Incredible. Wow.
Yeah. And it's in his book. I probably got that wrong. I read it the other day. I don't know if that's a global number or just the US. I think it's probably globally. But And then if you can, and it just keeping people who have really sharp brains, but their body let them down, or they had a clot, or they had a stroke. I mean, just think about it. And then that you're functional and your lifespan is good, and then bada boom, then you go wherever that is.
I am so excited for what we're going to do in Texas, and with yourself and your network and mine, and we'll reach out to David and Mark and some of these guys too, but we want to be a piece of the puzzle. We can't do it all, but we want to be a piece of the puzzle that helps to, as you say, lower the cost and democratize prevention using some of these new advanced technologies. Some of them obviously, learned through the experience that people like you've had working with NASA and space, and what we've learned from all that, and then are, bringing that down into new treatments and technologies that we can better understand the body. And from a preventative standpoint, I'm going to take you up on it. Like I said, we've already discussed this. I'm going to go through all these diagnostic and preventative tests that you and I have been talking about on offline. Very excited to have that experience.
Well, just let me know. I'd be happy to set it up for him. It's a great experience, and you learn so much about yourself. And then when we're given actually I'm dyslexic. I need pictures. I'm a spatial guy, and when I can see things and I can explain things to people, and you can reverse heart disease, you can reverse aging, you can reverse dementia, you can treat Parkinson's now, you can facilitate getting the right chemicals, whether they're chemicals to help something in your brain grow, or it's a chemical to kill, a cancer. They're able to deliver that with functional MRIs and with high frequency ultrasounds and with lasers. And then, like you said, with the AI and the quantum, it's going to be mind-boggling.
It's going to be, yeah. Any final question or last words from you, September, that you have?
I so hope that we have another opportunity to connect with you again. I'm fascinated by what you do. You have a very cool job. You had a very cool job. You did some very cool stuff in the world, and I'm fascinated by all of that. And there's just a plethora of questions and different directions that we can take in this conversation. I'm just so grateful that you stepped in and showed up today. Thank you so much for being here.
Thank you for having it. And that's what we need to do, is we got to get the word out to folks that this can be done now. You can do a lot of things now, and it's exciting. And we're going back to the moon, so that's going to be fun too.
Yeah, well, see, I didn't even get to ask you about your thoughts about whether we should be spending as much, maybe this is a can of worms, so we could leave it for another day, but whether we should be spending as much time, effort on trying to colonize Mars as we should be saving our own planet.
I think the moon is a first step, and colonizing Mars, it's going to be so hard. It's 6 to 8 months to get there. You got to stay on the planet 18 months and 6 to 8 months to get back. And you're going to get, first we have to go figure out how to take a solar flare. So one of the things we proposed is every astronaut should donate their stem cell. We should have their stem cells banked so that they're on the moon and there's a solar flare and they still can get down underneath the ground. You've got to dig to get under the dirt for protection. But if they have to if they can't do that and they get hit by a big solar pop and it takes out a lot of their DNA, now you can infuse their stem cells back in them as a treatment.
Wow.
That's a good way to leave it. So
yeah,
I think
cliffhanger moment.
It's fun stuff.
Yeah.
Appreciate you taking the time today. This was so enlightening, and we are so blessed and grateful to have you and to be able to, we look forward to working with you on what we're going to do in Texas, and hang out for a minute as we wrap up here. But thank you everyone for watching this recent episode of the most important conversations about health we're dealing with today. We're going to have a lot more of this coming your way. We hope you enjoyed it. So thanks for tuning in.
That concludes this episode of The Most Important Conversations. This in-depth conversation could set you on the path to self-improvement, which is essential if you want to be an effective leader and take meaningful action in your life. If you enjoyed this episode and want more of these stimulating discussions, you can find them at tmicglobal.com. Remember, the world is at a crossroads right now. You can't afford to waste this opportunity to take charge of your life, build meaningful relationships with others, and co-create a brighter tomorrow. Thank you for listening. See you on the next one.